Welcome to my end of term reflection. I will start with my personal timeline and then I'll end with my technical report. On January 20 of 2025, the first day of this course, my skills in software deployment were pretty simple. They were good enough for small monolithic projects. I did experience some continuous delivery since we did have jobs in our GitLab CI to automate the process of creating an artifact ready to be downloaded in SCP to an AWS container in the case of our 520 course. I've also experienced some sort of continuous deployment in 520 because we used Render, which redeployed our web app automatically upon new changes committed to the branch it was listening to. But honestly, I had no idea what the CI and GitLab CI meant, and I didn't even know terms like continuous delivery or deployment was even a thing. I also mentioned that I was concerned about how companies handle feedback, meaning receiving the feedback from the clients and then fixing them. I had no idea about this whole feedback loop and that there were other important sources of feedback to take into consideration. But throughout this course, I learned about those other sources of feedback. One of them are CI pipelines. For example, the pre-build job tells you if dependencies can be installed without errors. The test job can tell you if the server's unit tests all pass or not, and so on. We also have a combination of a health route in your server with an uptime monitoring services like Better Uptime, which can give you alerts almost right away if your server is down. Um, one last source of feedback that I wanted to mention is that you can instrument your app to monitor its performance and then visualize its telemetry data through dashboards. For example, perhaps you want to display things like CPU and memory usage over time and use that as an indicator to determine if you want to scale your infrastructure vertically or horizontally, for example. So here my perspective about feedback really has changed. It's no longer about just feedback from clients, but I've also learned about all those other aspects, sources of feedback that companies take into consideration. In previous semesters, I understood the importance of consistent and reproducible environments. Even this semester, I learned more examples of how and why it is important. If code works on your computer, then it should also work in production. Reproducibility is really important for GitLab CI jobs to ensure the feedback given by them are accurate, reliable, and relevant. This can be done with version pinning. So you list all your dependencies in the version in a configuration file like package.json and requirements.txt. And plus, thanks to these version pinning files, you can even take advantage of GitLab CI's caching feature to save on CI minutes. Okay, anyways, I'm getting beside the point. So another example why of in a consistent and reproducible environment is important is because let's say we have here the Django PyTest app, which is a Python app. So depending on what OS you're using, like Mac OS, Linux, or Windows, the command you need to run to set up your virtual environment will differ. And so having something like a container image will make it easier to configure configure and set up your Python app across different types of devices. Despite understanding like why it is so important, I never really got to experience why it is so important. Like, how is it really that important? But then Lab 3.3 happened. It's a lab about you set up a Docker file so you can run a C# project about mazes. And I just wanted to see what the app would look like on my computer before starting the lab. So I had to like set up my Visual Studio and everything C# related so I can run C# on my computer, right? Because I factory resetted my laptop during the winter break, so I lost everything. So I literally spent like 1 hour trying to remember how to download Visual Studio in the right version 6.0, what packages to install and keep or remove. I just literally forgot all about that, and after that 1 hour, I did not remember and I did not manage to run the app. So I just stopped there, I gave up, and I proceeded with the lab. And literally in the same amount of time, I was able to set up a Docker file and run the app, run the C# app through the container and see what it looked like. I also want to mention how this lab really improved my debugging skills in containers so much, because my usual debugging skills can't really be applied to containers. It's a bit different. Before, what I would do to like debug containers is like I run the container and then I docker exec into it, or I would docker logs the container if it's not even running or it's like down, and hope for the best. But then I got introduced to the dive tool in lab 3.2, and I'd use it so much in lab 3.3. I can now debug the file system at every single layer of a container image and pinpoint exactly which line of my Docker file is causing an issue. Okay, so now I'm going to talk about assignment 2. This assignment, we had to deal with so many new concepts. Not new, but concepts that we were beginners at. For example, we dealt with like not having one, but many Docker files. Many of them were multi-stages. We had to deal with like managing those Docker files, like using Docker Compose, and along with advanced configuration like health check, environment variables, Docker networks, Docker volumes. We wrote seeding scripts. We used .docker ignore. We also touched on nginx and reverse proxies. So for this assignment, like for an assignment, that's a lot of things involved. So it was the most challenging event for me, but it was also the most rewarding one. Talking about reverse proxy, it was at this part of the assignment where I had a very big eureka moment about something very silly. So initially we use Vite in development. It serves the website on the port 5173, and then you can even like configure it a proxy line where you specify something like localhost 3000. And so all API requests will be forwarded to the server localhost 3000. But now in production, I had to change my code so that I had a client container, a server container, and I was told to also add a reverse proxy container, which will sit between the client and the server. So I tried to put the reverse proxy between the client container and the server container, so that request sent to the client container will be forwarded to the server container thanks to the reverse proxy, just like how API requests sent to Vite on port 5173 are forwarded to the server API. But obviously, this did not work. After a good chunk of time of trying to debug this, trying different things, researching, it finally clicked in my head that the client container is also a server serving the website. This really made me realize that the reverse proxy sits between the client, as in the browser, and the server, as in the whole server, which in my case includes the client and the server containers. So as you can see, like many components and a good amount of research was involved in this assignment. It allowed me to like deepen my knowledge, but also to develop my searching skills, which in my opinion is a very underrated professional skills. The internet has so much information and resources available, so I believe knowing what is valid or invalid, where and what to search is a valuable skill. From my experience in this assignment, I've learned that instead of a simple Google search, sometimes it is better to search directly in the documentation. So in this assignment, Docker's documentation. And I've also learned that it can be useful to search public repositories available online that uses the same components or similar components to what you're using. So you have real life examples of how things are being implemented. Now that I understand better containers and the concept of automated and continuous deployment, my goal for the next 6 months is to learn how to deploy and manage thousands of them using Kubernetes. I found that Kodi Cloud offers an amazing Kubernetes course with many labs, and according to the calculator, it would take 6 months to complete if I spent 7 hours per week on it, which I think is realistic. Developers push new code and features consistently and frequently, while the operation team usually prefer to only deploy new code on a slower basis because they want to ensure that everything is thoroughly tested as much as possible to not introduce new bugs in production. DevOps is a set of philosophy whose main goal is to have a software development lifecycle that allows collaboration between developers and the operation team despite their differences in their workflow, so that new code can be frequently deployed while ensuring security, code quality, and shorter feedback loops, and so on. So CI/CD supports this DevOps mindset very well. But what exactly is CI/CD? Something that I wish I understood better throughout this course. CI stands for continuous integration, and it's about having a system that automates the process of integrating new code changes to a common branch, usually main or master, on a frequent basis. So, since new changes are often made, a CI pipeline is usually involved to run builds and tests with the purpose of ensuring that the new code is not going to introduce new bugs. You can also have jobs like linting, which checks that the syntax style is perfect to ensure code coherence across multiple developers. Now, in the CD of CI/CD, there are two aspects. First is continuous delivery, which comes first after continuous integration, and then the second aspect, which is the last one, continuous deployment. Continuous delivery is an automated process. It makes production code ready for release once and only once the CI step succeeds. This makes sense because let's say your CI step doesn't pass because I don't know, there was a failed dependency. Well, you don't want this code to be in production, right? Anyways, with continuous delivery, you can, for example, have an artifact ready to download and use. So if we take my 510 C# course as an example, I would have a job that would create the artifact ready to be downloaded and used. So what you would do is like you download this artifact and you open it, and there will be a executable file that you just have to click on it, and then the simulation game Paint Drops was running on your computer. Now, the second aspect of CD, continuous deployment, that is about automating the release of your code to deployment. So any new changes will actually affect all your users in real time. This also means that you will no longer need to manually deploy new code because continuous deployment makes it done automatically as soon as continuous integration and continuous delivery passes. So now that we know better what is CI/CD, I hope it's easier to understand how it supports DevOps. Matter of fact, CI/CD is actually considered one of the DevOps best practices by many, and that includes AWS. I personally really like CI/CD. I even incorporated all three: continuous integration, delivery, and deployment in my 620 projects. However, I didn't pay for any of the CI minutes I used, so maybe if I had to pay for that, perhaps I wouldn't have a CI/CD system because I would prefer to do everything manually myself for free. But honestly, if you can afford it, CI/CD is a must in my opinion.